It is 7.5 with Mr. Oliva for the last time. So, let's get started. Conversion. So, conversion factors. So, we're talking about going from degrees to radians. I like to use radians a lot, so this is a good topic for me. So, I'm just going to ask, Dora the Explorer style, how many radians are in a circle, unit circle? It's 2 pi radians. So, for all of my whiz kids out there, what would that make 180? Because 2 pi is the entire circle. So, if 180 is half of the circle, that would make our radians for 180 be pi. And then, so because we know from here to here is pi radians, and 90 is half of 180, then that would mean that 90 is pi over 2. And then if we were to take 180 and add a half, then we would have 3 pi over 2 radians for 270. So, now we're talking about conversion. So when we're converting either degrees to radians or radians to degree, we need what's called a conversion factor. And this conversion factor is... So we have to choose what that factor is going to be. And so I would think that the easiest one would be to use 180 in pi, because pi doesn't have a coefficient in front of it. So instead of having pi over 2 or 2 pi, I just have to deal with pi by itself. So when I'm converting degrees to radians, my conversion factor is going to be pi over 180. Because if I'm multiplying by some degree, if I'm multiplying, then I can eventually reduce my I would be reducing my degree size. So then if I'm doing radians to degrees, my conversion factor is going to be 180 over pi. Because then if I'm multiplying by some number in pi over 1, then I can reduce my pi's. So conversion factor is important to remember. Degrees to radians is pi over 180, and radians to degrees is 180 over pi. So now we're going to work with some examples. So we have 60 degrees. So 60 times, so remember our conversion factor, we're doing degrees to radians. So that means we're going to have pi over 180 degrees. Well, our degrees is going to reduce, and then we're going to have 60 pi over 180. So now we're going to practice reducing without a calculator, because so many people panic whenever they don't have a piece of technology in their hands these days. Jeez, come on. So an easy way to do this is to break it up. Break up these numbers. So 60 is the same thing as 6 times 10, right? We know that because we're in high school and we know that. And that when we can also see that 18 is the same, 180 is the same thing as 18 times 10. Well, we see these tens and we're dividing, so we can reduce those tens. And now we have, don't forget about pi, times pi. Can't forget about pi. Pi is a factor. And then we have 6 pi over 18. Well, 6 can break up further into other things, but let's just break up 18 first, and we see that it breaks up into 6 times 3. Well, we still have 6 times pi, and then the 6's can reduce, and then all we're left with is pi over 3. So that is our conversion. So 60 degrees is equal to pi over 3 radians. And if we go back and look over at our unit circle, there's 60 degrees. Well, there's pi over 3. So then this is the same thing as 60 degrees is pi over 3 radians. All right, moving on to the next one. So now we're going to erase this a little bit more. Moving into radians to degrees. So that means our conversion factor is going to be 180 over pi. So we know that these will reduce, and then we're multiplying, so go top to top, bottom to bottom, and that's equal to, well, we have 180 times 5, and we can't use our calculators, so let's do it the old-fashioned way. 180 times 5 5 times 0 is 0. 8 times 5 is 40. Carry the 4. 5 times 1 is 5, plus 4 is 900. So then we have 900 over 4. And then we know that 4 can simplify to 2 times 2, because we have to reduce without a calculator. So we're going to do it like this. 900 can reduce to 450 times 2. So then those 2's will reduce. And then we see that 2 can no longer reduce anymore, but 450 can reduce to, well, 450 divided by 2, using some simple division, is 225. So then it's not pretty. I mean, my bad, times 2, it is pretty. Because then we can reduce these 2's, forgot that. And then all we're left with is 225 degrees is 5 pi over 4 radians. So again, going back to the unit circle, 5 pi over 4 is right there, which is the same location as if we were to go 225 degrees. Oliva out.